Now, fiber optic cable runs on an entirely different principle. It's using the off and on pulses of light. Now, it's always in full duplex here, one for sending, one for receiving. 10 gigabit, much faster, much more throughput than copper. The speed's about the same. That's one of the great myths, is that fiber is faster. It actually just has more capacity, but the speed is still about the same because the glass cladding in there, slows the light down enough to where it's about the same signal speed as copper. So there's a cladding and a buffer strengthening, and then inside is the core. And the core would determine the types. There are two different types. There's single mode fiber and multimode fiber. And the difference is single mode is only a 9 micron, and it has one signal that's very strong. Generally, that's for long distance, carrying signals under the ocean. And it uses actual lasers. But the multimode fiber has quite a bit bigger glass core, and it can carry multiple signals bouncing at different angles and different paths. So it has a much bigger throughput, but the signal loss is greater, so it doesn't last as long. All right, it's still good for long distance, but much shorter than single mode. Usually this is within big buildings. You would use it to go between wiring closets, etc. So single mode and multimode fibers. When you look at them, you can't really tell the difference, but duplex multimode connectors here, and then single mode connectors up here. But again, you'd have to read the cable typing on the side to be sure of what it was, because the differences are barely visible to the naked eye. So these are the multimode and single mode patch cords that you can see. Different types of connectors, but still, the fiberglass. One of the assignments you have is to look at how fiber optics are made. You need a time domain reflectometer to test that cable. We won't be doing that in the lab. Those are very expensive. So fiber versus copper, again, they're about the same speed, but the throughput, the bandwidth supported, is much higher. It goes up to 100 gigabits a second, as opposed to 10 gigabits with copper. And the immunity to AMI, electromagnetic interference, and RFI, radio frequency interference, is quite high. So that's why fiber is good in buildings. You can run it alongside the electrical cables, and it doesn't much matter. But it is a little more expensive to work with. Another type of media that we're all familiar with now, and have become more so over the years, is wireless media. We use Wi-Fi, Bluetooth. WiMAX is pretty much gone, but that was popular in Fairbanks and other parts of Alaska for a long time, but its bandwidth is pretty small, just a couple megabits. So it doesn't work so well. Bluetooth is very near. You might have Bluetooth speakers or Bluetooth headsets. Works up to about 30 feet. And then Wi-Fi, different standards for Wi-Fi can take care of computer communication in buildings or in neighborhoods. So let's take a look at, let's leave media alone.